This is a video of a man who tried to front flip off a ledge, but as we can see, he failed miserably. As we go into a more slow motion view of this video, we can see exactly how hard he did hit the ground, and we can break it down a little bit more after this. In this first clip, there was a normal force and a force of gravity acting on the man. There is a normal force because the electrons in his foot are repelling the electrons in the ground. There is also a force of static friction because his foot is stationary when he pushes off, and it isn't sliding. The normal force becomes greater than the force of gravity as he pushes down with his foot because of the force his foot exerts on the ground. In this next clip, the man flies through the air because of his initial push off the ground. His push gets him off the ledge, but he is instantly affected by the force of gravity. The vertical acceleration of gravity is -10 meters per second squared, so he speeds up in his descent as he hits the ground. Newton's first law is that an object in motion or at rest will stay at motion or at rest until an outer force is put on it. We can apply this to this example when the man is in flight. When he pushes off the ground and throws his body forward, he is put into a flying pattern in the air, which is his front flip. He would stay in motion, but the outer force of gravity forces him to come back to Earth and fall on the ground. Newton's second law is that force equals mass times acceleration. Since this man has a given mass, we can say that his acceleration times his mass equals the force of gravity that is acting on him. We know that the acceleration of the force of gravity is -10 meters per second squared, and that is always constant. But the force exerted on an object is not always the same. Something with a greater mass will have a greater force of gravity, but fall the same as something smaller. We are often confused by this because we don't think about air resistance. A feather would not fall as fast as a man in real-world conditions, but without air resistance, it would. Newton's third law is for every action, there is an equal and opposite reaction that happens simultaneously and is the same type of force. As the man hits the earth, both him and the earth feel the same force from the fall. The man feels the force more because he has a smaller mass, and he is abruptly stopped as opposed to the earth, which has a much larger mass. Smaller masses have a greater acceleration when forces interact. The force of gravity is also an example of Newton's third law. Both these two objects feel the same force of gravity acting on both of them.